Okay, so in this section, we're going to look at differentiating and differentiating and integrating exponential functions. So we've done most of this before, so it's going to be a review for most of us. Just to kind of remember about the e to the x function, we have to remember its domain is all real numbers. Its range is from 0 to infinity. It's continuous on its domain. It's always increasing, and it's always concave up. Those are some of the things that we know about e to the x. If you recall from Math 3, this is the inverse relationship between e to the x. Okay, so this is a review. This is not calculus. If we wanted to solve for a natural log function, what we would do is exponentiate both sides. So I would, and since this is the natural log of, natural log, it has a base of e. So I write e to the fifth is equal to 2x minus 3. Then I just use algebra to solve that. So I get e to the fifth plus 3 over 2. For this one, what I have to remember is this is the property that the natural log of e to the 3x minus 1 is simply equal to 3x minus 1. Okay? So actually, I could also have said that that 17 is equal to e to this guy, because I'm going to end up with that anyway. Exponentiating both sides, I get e to the 3x minus 1. No, I don't need to do that. Why did I do that? If I'm solving for x, I would simply just solve for x. I wouldn't go backwards. That makes no sense at all. So I would just write this as the natural log of 17 plus 1 over 3 is equal to x. Okie dokie. And I got that one of the things you can remember when we have an exponent that drops, and then I have natural log of e, which is simply 1. Okay, so these are the rules. And again, we've done most of these before. And this is the rules for integration. Okay, so we want to find the derivative, so we have to remember to use chain rule. So we have to find the derivative of the inner function first. So the derivative of 4x squared is 8x. And then the derivative of e to the u is simply e to the u. Same thing here. I have to take the derivative of this function first. And remember, I can write this as negative 3x to the negative 1. So the derivative of that would be 3x to the negative 2. And then e to the u is simply e to the u. And of course, there's different ways of writing that and simplifying it. To integrate, we have to do a u substitution here. So if I let u equal to 3x plus 1, then du is equal to 3 dx. And I have dx in my problem. I don't have 3 dx, so I can then say 1/3 du is equal to dx. So then I have the integral 1/3 e to the u du, which is simply 1/3 e to the u, and e to the u is 3x plus 1. Let's see. Same thing here. I'm going to let u equal to 1 to the x, 1 over x, sorry. So then that makes du, because remember this can be written as x to the negative 1. So that makes du negative x to the negative 2, or I can write that as negative 1 over x squared dx. And again, I have x squared dx in my problem, and so I pull out a negative, and I end up with e to the u du, which is simply e to the negative, what was u, 1 over x? So 1 over x. Let's see. Okay, so again, I'm going to use the u substitution. So if I let u equal to negative x squared, then du is equal to negative 2x. okay, dx. All right, so I have x dx in my original problem. I can pull out that 5, so I'm going to write this as negative 1/2 du is equal to x dx. So pulling out the 5 and the 2, I get e to the u, that's a negative here, du, which is negative 5/2. I love e to the u. It's the easiest one to integrate. Negative x squared plus c. Okay, so we're doing u substitution, and it's a definite integral. So we're going to let u equal to 1 plus e to the x this time, because we always want du to be in the numerator, and that's going to be important when we get to chapter 6 as well. So du is not equal to dx, you know that. Du is equal to e to the x dx, which I have. So let's go ahead and change our limits as well. So I have u0 is equal to 1 plus e to the 0, which is 2. And then u of 1 is going to be 1 plus e to the first power, which I can't simplify. So putting everything in terms of u, I get 2, 1 plus e du over u. And because u is in the denominator, that gives me the natural log of u evaluated from 2 to 1 plus e. Now you might ask, why didn't I put that in absolute value? Well, I didn't have to, because I know I'm integrating over positive numbers, so I know that that's always going to be positive, so I don't have to put that in absolute value. So I get the natural log of, and then I go put it in there anyway. I do need a parenthesis or something around it. So I'm going to do the natural log of 1 plus e minus the natural log of 2. And I can't really simplify that any further, so it's going to stay the way that it is. And let's see, we have 2e to the x. So this looks a little strange. What should I make u? Well, remember, du always has to be in the numerator. So if I make u equal to e to the x plus e to the negative x, then du would equal to e to the x minus e to the negative x. Now, using chain rule, because I've used chain rule here. Now, that sort of looks like what I have here, but I can factor out a 2. Okay? So factoring out a 2, now my du is in my problem. And I can pull out that 2. So I can say 2, the integral of du over u squared. Okay, so u squared is u to the negative 2. So when we integrate, we add 1, so we get 2 negative 2 over u. Is that right? Because I can write that as u to the negative 2. I add 1, that makes it negative 1, and then I divide by negative 1. So they give me negative 2 over u plus c, but of course I can write that as negative 2 over e to the x plus e to the negative x plus c. Okay, so let's just find some applications of this. We want to find the equation of the tangent line to the graph at the point 1, 0. So in order to find the equation of the tangent line, the first thing I need is the derivative. So to find the derivative, I'm going to have to use product rule. So I get e to the x, keeping e to the x the same and taking the derivative natural log of x, I get 1 over x, plus keeping natural log the same, taking the derivative of e to the x, I get e to the x, natural log of x. Okay, so f prime of 1 is going to be e plus e times the natural log of 1, which is 0. Let's just get e. So the equation of the line would be y minus 0, and I know that from here, is equal to e x minus 1. And last, find the particular solutions that satisfy the equation. So we're given the second derivative, and we're given some initial conditions, and we want to find the first derivative. So the first thing I do is find the first derivative by integrating the second derivative. So f prime of x is equal to the integral of sine x plus e to the 2x. And that derivative, that integral, the integral of that gives me the first derivative, which would be negative cosine x plus, using u substitution, I make u equal to 2x, then du is equal to 2 dx, so 1/2 du equals dx, so I end up with 1/2 e to the 2x plus c, and I am told when f of 0 is c, when f prime of 0 is 1/2. So putting in 0 for my x's, I get f prime of 0 is equal to negative 1 plus e to the 0 is a half. E to the 0 is 1 times a half plus c, and that's equal to a half. So that gives me c is equal to negative 1 or positive 1. C is equal to 1. Okay, so now I have to find the second, the original function. So f of x is equal to the integral of negative cosine x plus 1/2 e to the 2x plus 1. And integrating that, the integral of negative cosine is negative sine x plus, again, I have to integrate this the exact same way, so that's going to give me 1/2 e to the 2x, which would be 1/4 e to the 2x plus x plus c. Okay, so using the initial condition, when f of 0 is a fourth, I get f of 0 is equal to the negative sign of 0, which is 0, plus 1/4 e to the 0 plus 0 plus c, and that's equal to 1/4. So that's 0, that's 0. Subtracting 1/4, I get c is equal to 0. So f of x is equal to negative sine x plus 1/4 e to the 2x plus x, and our c is 0. Okay, and I think that does it for this video. Enjoy, and we'll see you at the next video.